Okay, so I'm recording this one so that way you have access to this Chapter 7 review no matter when and where you are. Throughout the week, you may not be the same one who I'm recording, so you can refer back to whatever one's on Blackbaud. But everything we're doing is going to very much situate with what we have done this semester. So if you totally miss this week, let's say you, like Mr. Goodrow, are out sometimes, your best bet is to go back to our old reviews. You remember we did these before every test and we posted them online. Using those is your best bet. That's basically what we're doing this week with a little bit extra reteaching. So there's a little bit of reteaching here and there that I will talk about. Another thing, this is your formula sheets. It is 2 pages front and back, 4 total sides that we are going to be using. It is not in total order just because I wanted to make sure I had everything in the most efficient way to do it, so it's a little bit out of order, but I'm going to use this all this week. I just uploaded it to Blackbaud in the spring exam topic, so you can go download that and bring it if you'd like, but I will have it throughout the week. Please familiarize yourself with this. We'll have this plus a trig table, so it will be a lot of stuff to look at, but that's okay. We will be primarily in this section today. Make sure you have your test with you, and we're going to use that to help us through today. First thing we're going to talk about is basically what was the chapter about. The chapter itself was about 4-sided shapes. There will be no chapter 7.1 on the exam. We didn't put that on the test, so we're not going to put it on the exam. It's going to deal only with 4-sided shapes. This section talked about sides that were infinitely bigger, and we had what is the interior angles of a 7-sided shape, for example. And so that was what 7.1 dealt with. We're only going to deal with 4-sided shapes. Primarily, that was parallelograms. What I'm going to do here is show you a very rough version of your formula sheet. We did this together before the last one. Parallelograms. We have a bunch of properties that come from parallelograms on the formula sheet. For example, we had opposite sides are congruent. We had opposite angles are congruent. And on and on. The definition of a parallelogram was 2 pairs of parallel sides. So this side being parallel and this side being parallel was our whole idea of what is a parallelogram. We had some ways to prove them, which are normally the same properties, but that was our start. We talked about parallelograms for 2 sections worth of time. On your formula sheet, I'm mimicking this part right here. Inside parallelograms, we have 2 other specific shapes. We have a rhombus and a rectangle. Inside of a rhombus, we have one thing. Inside a rectangle, we have another. If you see, I've drawn them very particularly with an overlap. This is like a Venn diagram with an overlap. That overlap is for squares. What is the defining trait of a rhombus? Anyone remember? Yeah, go for it. Anyone remember the defining trait of a rhombus? Here, Jack, go show them real quick. All 4 sides are going to match. That is like the defining thing about a rhombus. All 4 sides are the same size. Rectangle is the diagonals are the same length. Diagonals are congruent. And then a square, all of those things are true. A square, we don't have any particular things for squares. It's just when all of our properties match up, when all of our properties line up. There was also, briefly, we talked about opposite sides are congruent. Yeah, I talked about that. In addition to parallelograms, rectangles, and rhombi, we talked about trapezoids. Trapezoids and kites. We kind of put the least amount of emphasis on kites, and we didn't put too much on trapezoids. They are where one pair is parallel. So one pair is parallel. Sometimes these match, but sometimes they don't. And like I said, kites, we really didn't put a lot of emphasis on them. I want to do one of each of these questions after we talk extensively about this box first. There's a very detailed version of this sheet on Blackbaud in that chapter folder. If you remember, we talked about it while we were learning it. There's a full detailed version of this sheet, as well as the formula sheet, which is somewhere in the middle. It's not totally fleshed out with every piece and diagrams, but it's pretty good. It's got all the major pieces. I updated it today. I did have this earlier from the book, and it was just a list of properties, but they just weren't good enough. They wouldn't have all the stuff. So your new formula sheet, as of right now, looks like this. So your test, let's use that as our study tool. Your test is a really good vehicle to show you how I'm thinking through problems I'm going to give you. We have, let's start with a question. I think it was on your quiz, but didn't make it on your test. I'm going to make up a shape, or 3 points, and we're going to find the 4th point of the parallelogram. So if that's 1 point, and that's 1 point, and that's 1 point, where is my 4th point? To do that, I'll write out the points over here so we can see them. This is 3, -3. This is 1, 1. This is 0, -2. There are a bunch of different places there's 3 different places we could put it. And let's say I told you it's somewhere over here. Let's say it's somewhere over in this area. Well, the main thing about a parallelogram is that opposite sides are parallel. We can use the pieces we have to construct something to find our missing piece. Opposite sides are parallel. One way to do this is to say, well, how I went from here to here is the same to go from here to here. So how did I go from here to here? Well, I went 1, 2, 3, and up 1. So for example, I went left 3 and up 1. I could do that exact same thing to construct this. So that'd be 1, 2, 3, 1, 2, 3, and then up 1. That means that point right there should be my final one. Once again, the same way I did 1, I can do the other. It's not a very mathy question. We're not solving and putting it in a variable, but I can use how I did 1 to do the other. And that gets me my other point, for example. So that's just a simple way to understand parallelograms. You use a little graph to find that. Parallelograms are like the soul of this chapter. If we understand those, that'll help us with everything else. Next, I want to move to a question like number 3 and 4 on your test. And this point, if you can't see it, is -2, 2. I will scan all these up at the end of the day and upload them so they will also be in the spring exam topic folder. That way you have access to these and all the other classes. You can see sometimes I do slightly different numbers, but it's the same idea. So that'll be scanned today and throughout the week. Okay. Let us jump to a problem. I want to do number 3 on your test. So this is number 3 on the test, if you want to follow along. I'm not really going in section by section because this one especially, they all kind of mix together, and this question kind of digs into all those sections at once. So what shape is below? We have the side lengths and the diagonals. The sides, we have AB is 9, BC is 4, CD is 9, and DA is 4. We have AC is 9.8, and BD is 9.8. Okay, so for example, this is like number 3 on the test. If you want to follow along, I could make up new ones. I think that they're just as good as the test. And I also want to kind of show you how to study for using your tests, because I know it's not as easy to make up problems. What do I notice about the shape, about these numbers? Anything that sticks out?
They each have a pair.
They each have a pair. For example, 9 and 9, 4 and 4. That right there tells me opposite sides are congruent. Opposite sides are congruent. Yes, that lets me know it is a parallelogram, for sure. So in our map, that's really what this is. It's a map. We are definitely in this box. It is not a trapezoid and it is not a kite. We are in this box. What else do I notice about this stuff? Diagonals match. Diagonals match. Diagonal are congruent. So it's at least a rectangle. It's at least a rectangle because the diagonals match. We go over here. So I am in this box. I've now whittled it down to rectangle or square. One of those two. Is this a square?
No.
No. All of the sides don't match. So it's not a rhombus. And it has to be a rhombus and a rectangle to make a square. So all this is a rectangle. This is a rectangle because opposite sides match and diagonals match. If you looked at number 4 on your test, the diagonals did match, but these don't always match. And that was an isosceles trapezoid. If you look on your test, that is an isosceles trapezoid because AB and CD matched, but those did not and those did. So that's one kind of question where you're just using your map, your formula sheet, to kind of identify what shape is it. I like these a lot because you're not doing any of the math. We will do one next where you are finding these values. But these, if you know your rules, it's just kind of testing that. Do you know the rules of how these shapes are constructed?
What, oh my god. What makes it isosceles?
Trapezoid?
Yeah.
The isosceles of the trapezoid is the diagonals matching.
Okay.
Oh, I need to add that to your formula sheet. So add diagonals match. Thank you. Good job, Charlie. Okay, so let's do one where we have to do the math. I'm going to do from your test, number 5. Do number 5 from the test. So we're trying to identify the shape. Again, it's the exact same thing. L is -1, 1. M is 3, 4. N is 7, 1. And finally, O is 3, -2. Okay, we're trying to figure out what shape this is. We have a couple ways to do this. The way I always told you I think you should do it is to mirror this and do 6 distance formulas. I know that doesn't seem like the easiest way, but I think having these 6 values is the quickest way to do it. It's the quickest way to know exactly what kind of shape you're dealing with. If you remember the distance formula, I just put that on the formula sheet. It is how x changes squared plus how y changes squared. I'm going to do LM, MN, NO, and OL. Those are my sides. I just go from one to the other, one to the other, one to the other, and back over. Those are each of my sides. For it to be a parallelogram, these and these need to match. They don't have to be the exact same. So how does x change? Well, what is the difference between -3, or 3 and -1? How far away are those two numbers? They're 4 away, yeah. So it's 4 squared plus, what about this? 3 squared. 1 and 4 are 3 apart. These are 4 apart. Now m to n. 3 and 7 are 4 apart. 4 and 1 are 3 apart. Okay. N and O, that's another 4 and 3. Okay, this is interesting. What have we noticed after we've done the first pass of stuff? Everything's matching. It doesn't exactly matter what the number is. All that matters is it the same number again and again? Is it the same number again and again? 2 things. Yes, it is. First off, these match. So, yes, it is a parallelogram. But also, all of these match. So, yes, a rhombus. This is not enough to say one way or the other, because at this point it could be a rhombus or a square. What we've done is we've isolated this box right here. We could still have a square, so we're going to do the rectangle test to see, are we in here or are we out of here? Which one are we in? That's the last part. Rectangle is just, do I check my diagonals? My L and jump over to N, and my M jump over to O. So I'm going to do 2 more distances, M and O and L and N. So I'm not looking for this number anymore. I just want them to match. So it doesn't have to be 25, as long as they're matching. That's, we are seeing, where are we on this box? Well, we're definitely parallelograms, and we're definitely rhombus. Okay. And so we're seeing, are we square or rhombus? So we've eliminated just about everything. Same thing, M and O, that is 3 and 3 is nothing apart. And 4 and -2 is 6 apart. Okay? L and N is, what is it? 8 apart. I was about to say 6 because I saw the 1 and the 7, but no. 1 and 1 are 0 apart. So, these are not equal. These are not equal, so it doesn't pass our rectangle rule. So, it is just a regular rhombus. It is a rhombus because it is for sure a parallelogram, for sure a rhombus, and it is not a rectangle, also known as not a square. So it is just a rhombus. Now, there are other ways to do this test besides doing 6 distance formulas, but I don't want to emphasize those right now because I want you to kind of have one series of things you do to get an answer. Also, before we move on, I'm going to add one quick thing to this page. Like that. So, more like Sayer, am I right? Not a star. Okay, so, quick note on that one. Yeah, Also, quick tip in what the questions on the exam will be. Your multiple choice questions are going to be questions that are very quick and easy. And your free response ones, I want to maximize partial credit. So whatever problems give you the most work to give you the most partial credit will probably be your free response problems. Not necessarily the hardest stuff, but whatever gives you the most partial credit. All right, questions on this before I move on? Cool. So, most of your studying for Chapter 7 should be understanding how you can know where you are on this grid. I'll update this, that'll help you out a lot. And then I want to do 2 more questions, 2 quick ones, with a kite and a trapezoid. Yes. Exact same Scantron. You do not have to have a pencil to do it. You can use whatever mark-making device you have. Yeah. Okay. I want to do 2 more questions. A trapezoid mid-segment question and a kite question.
Is this the same unit?
Yes. Trapezoid mid-segment theorem. We have a trapezoid. Any old trapezoid will do. Where this part is parallel to this and these are not. It is not a parallelogram. We have a special property that works with all trapezoids. If I create a mid-segment right here, where these match and these match, and if we say this top one is length A, and this bottom one is length B, what is the length of the middle one?
Why would you cut it that way? Why do you not cut it to like make it a triangle?
This is just the middle of these two. Like if I cut this in half right here and cut this in half. It is. It is the average of A and B. It is the average of A and B. This was on your test. This was on the back page. This is probably the most gotten correct answer. 11, 14, and X. We have a couple options. If we know this is 12 whatever long, and this is 16 whatever long, this average would be the average of 12 and 16, which turns out to be 14. Conversely, if we were given the middle but not one of the ends, we can do the same thing of like stair stepping. Because it's only 3 numbers, we can know it's going to go up the same amount every time. So if we were given just the end numbers, or just the middle number and one of the ends, we can do like a stair step method, kind of like your test. Your test, I give you 11, 14, and you don't know. So it's either the average going this way or stair steps. Trapezoid mid-segment theorem, and that is on your sheet as well. It's right here. B is A plus C divided by 2. So they did A and C. I just did A and B. Questions on that? These are the kind of questions I love for multiple choice. They're just quick, straightforward, hopefully 3 easy points. Okay, let's do a kite problem, and then I will open the floor up for any and all questions. So, kites. I'm going to do number 8 on the test. Number 8 on the test. Pretty straightforward. Looks something like this. We knew a couple things we know about kites. We really didn't spend a lot of time on kites. It was at the end of the unit, and we just had other things we were focusing on more, and there's only one kind of real idea we talk about, and it was this angle matches this angle. So I put letters to it. This will be X, this will be W, this will be Z, and this will be Y. Z and X are going to match always, and W and Y are going to always not match. Only one pair matching sides. So knowing this is 78, knowing this is 136, I can actually find the remaining pieces. So angle Z, how do I know angle Z?
It's the same as X.
Yep, angle Z matches angle X, so angle Z is 78 degrees. 78 degrees. Now that I know that one, how do I find Y?
You add them all up and subtract from it. What would you subtract from it?
Add them all up to add up to 360. Four-sided shapes add up to 360. In case you forget that, on the kind of collected just stuff on your sheet, I put this. Angles in a quadrilateral add up 360, angles in a triangle to 180. So that's on the back and kind of this no man's land of your sheet. And that leaves us with angle Y being equal to 68 degrees. And that's how we can find this from just two givens. This is the same question as on your test, number 8. Hello? Yes, send right down. Bye. Right. Okay. So that gets us to kites, and that gets us to a very high-level overview of all the things we have done. Any questions right now